Alright, so this video we're going to look at probability involving not and or, and we're going to look at odds. Alright, so the first thing we'll look at is events involving not. So this right here is pretty important. It can really come in helpful. It come in handy when you're calculating probabilities, and you'll see what I'm talking about when we get to the examples. So the complement rules of probability, which we have right here, says the probability that an event E will not occur is equal to 1 minus the probability that it will occur. So you write it out. The probability of not E, of not the event, is equal to 1 minus the probability of E. And then the probability that an event E will occur is equal to 1 minus the probability that it will not occur. So the probability of E is equal to 1 minus the probability of not E. Now, all that's doing is if you look at these two right here, it's the same thing. All they're doing here is taking this and moving it to the left-hand side and moving this to the right-hand side. See, this will change from a minus to a plus, and this will change from a plus to a minus. That's all they're doing, is just rearranging this one. Okay, and that's, finding the probability of an event not occurring, of not E. And I think this will make more sense when we get to the example. And then if we want to use set notation, this is just a different way to write this. Basically, it's a different way to write not E. We just use E complement. Okay. If you watch the other videos in these contemporary math lectures, we went over this symbol here. That's E prime, which means the complement of E. And so that's the same thing. See, the probability of not E, or the probability of the complement of E, is 1 minus the probability of E. All right, so let me show you where that comes in handy. So if you were dealt one card from a standard 52 card deck, then find the probability that you are not dealt a queen. Okay, so I understand in this problem it's not difficult to find out how many cards are not queens. Because remember, probability, that's the number of successful outcomes divided by the number of possible outcomes. All right? So the probability of not a queen. All right, so what we just went over, that complement rule, okay? So we know that there are 4 queens in the deck, right? We know that. So if I do 1 minus the probability that there is a queen, you see that? That's this right here. That's all I'm doing right here. The probability not a queen is equal to 1 minus the probability there is a queen. Okay? And so this would be 1 minus, and then if you look at this, the probability of a queen, well, how many queens are in the deck? 4. And there's 52 cards total. So this would be 1 minus 1 over 13 when we reduce the 4 over 52, and then we get 1 minus 1 over 13. That is equal to 12 over 13. You see that? Now let's do this. Let's come down here, the probability not a queen. And let's not use this. Let's not do 1 minus queen, the probability that it's a queen. Let's count how many cards there are in the deck that are not queens. So we know there's 52 cards in the deck, and there's 4 queens. So that means 48 of the cards are not queens. And we put that over 52. And so if we do 48 over 52 and we reduce that, that gives us 12 over 13. So see, you're going to get the same answer either way. But sometimes when you're trying to figure out, like in this case, not a queen, it's a little more difficult to see how many cards are not queens versus just doing, okay, well, I know there's 4 queens in the deck, so I'll do 1 minus that. Okay, because I want to know how many are not queens. So I'll do 1 minus how many are queens. And that's the whole concept of this complement rule. It makes it easier, and I understand it's not that difficult on this one, but some of them it can be a lot more difficult. It's a whole lot easier on some problems to use this complement rule. Okay. All right. So what about this? You are not dealt a diamond, so the probability not a diamond. Well, we know how many diamonds there are, right? There's 13 diamonds. So if we want to know not a diamond, we can do 1 minus the probability that there is a diamond. And so that's going to be 1 minus, and how many diamonds are in the deck? There's 13 diamonds, and that's over the total possible 52. Now, if you're struggling in the video, if you're struggling with, well, I didn't know there was 4 queens, or I didn't know there was 13 diamonds, what I would recommend is Googling deck of cards, and it tells you what's in there. Okay, it's assumed you know what's in a deck of cards. All right, and so this is going to give us 1 minus 1/4, which is 3/4. All right, and that's the whole concept of doing this, of doing the complement rule. It makes it easier to do. Okay. All right, so let's look at this. Let's talk about mutually exclusive events. If it is impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive. Okay, so we're talking about mutually exclusive. So that means that they cannot happen at the same time. Okay, that's what it means. It can't happen at the same time. So I guess an example of that is let's suppose that you randomly select one card. You're going to select one card from a deck of 52 cards. And let's say event A is selecting a king. Event B is selecting a queen. Okay? So if you select one card, it's impossible to get both a king and a queen, right? Because if you select one card, you're not going to get a king and a queen at the same time. That's what a mutually exclusive is. Mutually exclusive event. Okay? It's impossible for them to occur simultaneously. Now let's look at this, or probabilities with mutually exclusive events. So if A and B are mutually exclusive events, then the probability of A or B is the probability of A plus the probability of B. So if I want to know what's the probability of me getting this or this, okay? So what's the probability of getting A or B? Well, that's just the probability of A plus the probability of B. And the way that you might see it written a lot is you may see it written with union. Okay, this is the same thing. It's using a different notation. So this is the probability of A union B, or you can say probability of A or B is the probability of A plus the probability of B. So if you see this or if you see this, they mean the same thing. Okay. All right. So let's look at this. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? So we want to know the probability of selecting a king or a queen. That's what we're looking for. All right. So that is just the probability of a king plus the probability of getting a queen. So the probability of drawing a king is what? Well, there's 4 kings in the deck, and there's 52 total cards, plus the probability of getting a queen, that's 4. There's 4 queens, divided by the total number of cards in the deck. And so this, when we add them together, that gives us 8 over 52, which is 2 over 13. And that would be your probability. All right. Now, what about OR probabilities with events that are not mutually exclusive? So if A and B are not mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, minus what they have in common. And then once again, using the set notation, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. All right, so this means the same thing as this, and this means the same thing as this. All right, so you can write OR, and you can write AND, or you can use the union symbol or the intersection symbol. All right, so let's work through these next couple of examples, and then I want to go back up here and touch on something. So it says in a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy grooming their neighbors and screeching wildly. If one baboon is selected at random from the group, find the probability that it enjoys grooming its neighbor or screeching wildly. All right. So let's write down what we're looking for, the probability of. So the probability grooming, or, and I'm just going to write wildly. That's for the screeching wildly. Okay. I guess I can just, let's write this. Let's write it screeching. So what's the probability if we select one baboon at random that they enjoy grooming or screeching? So that's the probability grooming plus the probability screeching. I'll tell you what, I'm going to do this. The probability grooming plus the probability screeching. I just, instead of writing the words out, I'm just going to write the first letter, okay, because I'll run out of room over here. Minus the probability grooming and screeching wildly. Okay. Now, how do we know that these events, okay, see, these events are not mutually exclusive, are they? Because if you think about it, for one thing, it says 10 enjoy grooming and screeching wildly. It tells us that in the problem. But think about it. Could a baboon be grooming and screech wildly at the same time? Yes, it could. Okay? So those are not mutually exclusive. Okay? They're not mutually exclusive. So the probability of grooming, okay, the probability of grooming, that would be, well, how many enjoy grooming? That's 18, right? 18 enjoy grooming divided by the total possible. Well, what's the total possible? Well, it says in a group of 25 baboons. So there's 25 total plus the probability that they enjoy screeching. Well, there's 16 that enjoy screeching. So that's 16 over the total possible minus what they have in common. Probability that they enjoy grooming and screeching, well, that's 10 that enjoy both of them. So that's 10 over 25, right? So that's going to give us 24 over 25, and that's the probability, all right? All right, so let's look at this one. And just hang with me on this. I'm gonna work some. I'm gonna work this problem, and then I'll work this one, and then I'm gonna go into a little more detail about this, and it's gonna clear up everything. It's gonna clear up, and it's gonna make sense of why this is in the formula and why they don't have it in this formula. So just hang with me through the next two examples, and it's gonna clear that up. All right, so let's look at this. We have a spinner. It says, given the spinner below, what is the probability the pointer will stop on an even number or on a number greater than 5? Okay. So I know I don't have a spinner drawn on here. I guess we could maybe come up here and, if you had a spinner like this and you flicked it and it went around. Okay, you have this spinner and you thump and it goes around. What's the probability that it lands on an even number or on a number greater than 5? All right, so the probability even or greater than 5. I'm gonna abbreviate greater than 5. I'm gonna abbreviate that as G5, greater than 5. So probability even or greater than 5. So this is the probability even plus probability greater than 5 minus the probability even, and now I'm gonna have to come down here. Probability even plus the probability greater than 5 minus the probability even and greater than 5. All right, so there's our formula written out. Okay, so what's the probability that we get an even number? Well, how many even numbers are there? There's 1, 2, 3, 4. So that's 4 over the total possible. There's 8 plus a number greater than 5. Okay, greater than 5. So how many numbers are greater than 5? 1, 2, 3. So that's 3 over 8. Minus the probability even and greater than 5. So how many numbers are even and greater than 5? That's the 6 and the 8. So there's 2 of them, 2 over 8. And that ends up being 5/8. All right. Now, I hope you can maybe see now why we subtract this off right here, what they have in common. Hopefully you can see that now. If not, don't worry about it. After I work this next example, I'm going to explain that. And you may also have a question, well, how do we know when to subtract off what the and part? How do we know to put that, or how do we know not to put it? Okay, I'm going to go over that in a little more detail too. But let's first work this next example. All right. It says if one person is randomly selected from the population represented in the above table, find the probability. The person is divorced or male. Okay. So for part A, probability divorced or male is equal to the probability divorced plus the probability male minus the probability divorced and male. Okay. So what's the probability that someone is divorced? Okay. Well, here's the column for divorced. All right. Let me see if I can widen that a little bit. There we go. All right. So here's the column divorced. So how many people are divorced? Well, there's 11 plus 15. That's 26 total are divorced. So that's 26. Right? 26 divided by the number possible. Well, see, it's nice in this one because they tell us the total, this 254. Okay. Now, keep in mind this this row right here and this column over here, they don't have to give you that. The way that they get these, the way they get this is they just added these numbers up to get a total, added these numbers up to get a total, added each of these columns to get these totals, and then if you add this and if you add this, those are both going to add to 254 for the total. So that's how they got that. So if they don't give you a row for the total or a column for the total, you can actually just add that yourself and just add them up. And then we have plus the probability that they're a male. Well, the probability of male, well, there's 123 total males. See that on that row? 123 divided by the total possible, minus the probability divorced and male. Well, if you look at this, you see the divorced and male right here. See male and divorced where they intersect. So that's going to be minus 11 over 254. And that is going to be equal to, that is what, 69 over 127, which is about 0.54. So that's your probability. Now, let me go over right here and explain. Hopefully you can see it, but let's explain now why that is in the formula, okay? And how do we know when to put it, when not to put it? So if we look at this, so if you see, the first thing we did is we looked at the probability divorced. So we counted all this up, right? We did the 11 plus the 15, and that gave us a total of 26. And then plus the probability of male, we did this row right here, and that gave us a total of 123. This gave us a total of 26. But we added all of these numbers up. And see, we added all these 4 columns and got the 123. We added these two rows and got the 26. Well, look what happened. When we added these up, the 11 was included, and when we added these up, the 11 was included also. So it's like we added the 11 in there twice. And then what we're doing, since we added the 11 here and the 11 got added in here, we're saying, okay, what do they have in common, which is this right here? That was counted twice, so we're going to subtract it out. Okay? So that's why this part's in here. It's subtracting it out because you counted it twice. All right? So this probability here, let's just write it down, 0.54. That's the probability. All right? So now, how do you know when to put this and when not to put it? Well, as far as putting the and in there, you can put it in there every time. You cannot go wrong putting it in there in the formula. Because what's going to happen, well, I'll show you on this next one. It actually works on the next one. So let's just look at it there. And what we'll do is when we write the formula, we'll go ahead and put the and in there. Okay? We'll put the and in there, but we don't need it. And I'm going to show you how it still works. So for part B, I want the probability married. Well, I'll tell you what, let's do this. Probability married, well, we need to write out married and divorced. So that's the probability married plus the probability divorced. And this is all we need to put. We don't need to put the probability. We don't need this part. Married and. We don't need that. But we're going to put it anyway, and I'm going to show you how it doesn't affect it if you do put it. All right. So the probability married, well, there's 133 over 254 plus the probability divorced, which that's 26 total. So 26 over 254 minus married and divorced. Well, here's married, here's divorced. They're mutually exclusive, right? What do they have in common? Well, they don't have anything in common, do they? It doesn't intersect anywhere. So that would just be 0 over 254. So you see, if you do put it and they have nothing in common, it's just going to be 0 over the total possible. And that term's going to go out anyway because this will go to 0. And then you just add these two up. And that's going to give you 159 over 254. And that is going to be 0.63. And so this answer here is 0.63. So I hope that clears that up on the doing those probabilities when we have events that are mutually exclusive and when they're not mutually exclusive. Okay. All right. Now what about probability to odds? We want to know the odds. What are the odds in favor or what are the odds against? So if the probability of E is the probability of an event E occurring, then the odds in favor of E are found by taking the probability that E will occur and dividing it by the probability that E will not occur. So the odds in favor of E is the probability of E over the probability of not E. Okay? And then the odds against E are found by taking the probability that E will not occur and dividing by the probability that E will occur. So the odds against is the probability of not E divided by the probability of E. Okay? All right, so you roll a single 6-sided die. Find the odds in favor of rolling a 2. Okay, odds in favor of rolling a 2. So let's just go ahead for first let's write down our sample space. 1, 2, 3, 4, 5, 6. That's all the possibilities that we can get, right? That's all the possibilities we can get. So event E, that is the odds in favor of rolling a 2. So that's getting a 2, right? That would be the event E of rolling a 2. So we know for part A, the probability of E happening is the number of successful outcomes, which there's 1, divided by the total possible, which is 6. Okay? So remember, the odds in favor is the probability of E divided by the probability of not E. Okay? So I've got the probability of E, but I need the probability of not E. And this is actually where that complement rule that we learned at the first, that's going to come in handy here. Because if we've got the probability of E, then the probability of not E is 1 minus this probability, which is 5/6. All right. So now we can say the odds in favor, okay, the odds in favor of rolling a 2 is equal to the probability of E divided by the probability of not E, which that's going to be probability of E is 1/6. Probability of not E is 5/6. And so this is 1/6 divided by 5/6, or 1/6 times the reciprocal. Remember that? And so the 6's cancel, and we get 1/5. All right. So the way that you normally write odds is you would write the odds are 1 to 5. Okay. So the odds in favor of rolling a 2 are 1 to 5. Now, what about finding the odds against rolling a 2? Okay. What do you think that might be? Well, if we found the odds in favor, let me move this. So that's 1 to 5. So if we found the odds in favor of rolling a 2, the odds against it, well, we just reverse those. That would be 5-1. Okay. And if you wanted to, odds against rolling a 2 is the probability not E over the probability of E. And you can see all we're doing is flipping this. So it's just like we're taking the reciprocal of this, right? But if you wanted to work it all out, you could. That'd be 5/6, 1/6, which is 5/6 times the reciprocal of this, 6/1, which is 5/1. So that would be 5-1. So if you find the odds in favor, and then they ask you to find the odds against, you just switch them. Okay? That's all you're doing, is switching them. All right, so how about this one? The winner of a raffle will receive a new SUV. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against your winning the car? Okay. All right, so let's let E equal event of winning the car. Okay, that's what we're going to call E. Or instead of car, we'll call it what it is, SUV. Okay, so the probability of E is equal to what? Well, you purchased how many tickets? I know it says it somewhere. The winner raffle, and you purchased 10 tickets. So that's 10 over 500 were sold. So that's 500, which is 1 over 50. So that's the probability that you win the SUV. So the probability of not E, so the probability you don't win the SUV, well, that's that complement rule again. That's 1 minus 1 over 50, which is 49 over 50. Okay? So we want to know the odds against, right? So odds against E, where E is the event of winning the SUV. So the odds against, remember, that's the probability not E divided by the probability of E. So that's going to be 49 over 50 over 1 over 50. And so that's going to be 49 over 50 times the reciprocal of this, 50 over 1, which is 49 over 1. And so the odds against are 49 to 1. All right. All right, so this is the last part. This is our last example. So that time we went probability to odds. Okay, we could calculate the probability and we would find the odds in favor or the odds against. So here we have if the odds in favor of event E are A to B, so they're telling us that the odds are A to B, and remember, you can write those odds like that. That's how we were writing them, A to B. Then the probability of the event is given by the probability of E is A divided by A plus B. Okay, so let's look at the example. This is really easy. The odds, that should be odds. So the odds in favor of a particular horse winning a race are 2 to 5. What is the probability that this horse will win the race? Okay, so the odds are what? 2 to 5. Well, look at this. There's A, there's B, right? See, A to B. And so the probability what happened there? All right, so let me erase that. All right, so the probability the horse wins the race, all right, that's what we're looking for. Probability that this horse will win the race is what? There's your formula, A over A plus B. So 2 over 2 plus 5, okay, which is 2 over 7. So that would be the probability that the horse wins the race, 2 sevens. And, you know, if you want to get a percentage, you just do 2 divided by 7, which is, that is actually equal 0.286, which that's 28.6% chance that they win the race. Okay, so that right there could actually kind of help you decide what the odds, what those odds mean. You can just take that and see, okay, you got a 28% chance of winning. So, you can pick your odds based on, well, I want to make sure I have 50% or better to win. Okay. Or 40% or better to win. So you can calculate that when you have the odds, because when you go to the racetrack, that's how they give it to you. This horse is what, 4-to-1 or 1-to-40 or something like that. And now you know what it means. Now, I'm not telling you to go out and gamble or anything on horses, but that's a real world application there that you can look at. So I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.